agentic system. And we have today several, in our group also, several statistician researchers, then also will look from this pluralistic side what is possible, how to constrain large language models, how he did it effectively. Please welcome our speaker, Julian Wiffen.
Thank you. Cool. You can keep that one. Yeah. Cool. Okay, thank you, and welcome. To give a little bit of an introduction, this, in some ways, is culminating a journey that started with the tall gentleman, bearded gentleman at the top there, hiring me about 4 years ago to join Matillion, although he is no longer with Matillion, although I still am. First of all, welcome to our offices here. Thank you for listening. I hope this content will be relevant to a large number of you. We might not get everybody. It obviously has to be a little bit generalized for the audience. Some of you may know more about some of the programming side of things than others. Some of you may be more interested in the AI pieces. What I'm going to talk about tonight, however, mainly is ways in which we've genuinely built functionality that is available in the software product today. In fact, most stuff's been live for about 9 months now, being sold to various used by various large enterprise customers. This isn't I'm not talking about pipe dreams about what might be. I'll touch a little we're working on, but the majority of this stuff is live and available today. To give you a bit of an agenda, if my slides have woken up. So I'm going to talk a little bit about the problem our agentic system is addressing. Hopefully it won't be too salesy a little bit. It's a word of words from our sponsor, but I want people to understand that here's the challenge we're going after. We'll talk about what do we mean when we say we've built an agentic data engineer. Maya, which you see branding all around the offices for, is what we call an agentic AI data engineer. It's an assistant to help you build and transform data, move it into the right shape, and use our software in a way that's a lot faster and more efficient than traditional formats. I will do a brief demo, usually because we're quite proud of what we built. We'll talk a bit about what it's done for some of the customers. Again, I'll try not to make it too salesy. I don't think this audience will probably appreciate that. But we'll move on to the last chunk of it. We'll talk about, okay, well, how do we build it? What have we learned along the way? I'll talk about thinking inside the box, which means constraining a large language model and constraining its output in a way that gives you control and the impact that has on its usability. And also I'll talk a chunk about how we're seeing use of the agentic tools, both of Maya and our customers, and our own tooling, changing the way teams work and change their impact on people's roles and the skills we need, and also just the way people are working. If anyone's got questions during this, please do feel free to raise a hand. We can get you a mic to speak. I'll happily take more questions at the end, but if there's something particularly relevant, feel free to shout and stop me, and we can cover it then. So, problem we're tackling, or the pieces we're tackling here, why we think this is valuable. Huge number of enterprises want to deploy AI. It's very exciting. It's got a lot of potential. Everybody believes it's got a lot of potential. But a lot of the time, the AI goes nowhere without the data. Now, so in part, we're selling to chief data officers, and there's a danger that they get scapegoated as the convenient excuse as to why the shiny AI project didn't work, which was the data wasn't ready or it was too messy, because it's all the business we're kind of in. But organizations have got data prior to AI. There's all sorts of patchwork quilts cobbled together of multiple systems inherited or been there as a legacy. Cost and effort to maintain them, and obviously a lot of potential gaps that arise because they're coming from different tools. It's hard to merge stuff together. The stack itself is always complex. Because of that, there's almost always a lot of manual work in moving things from one place to another, or wiring them together, or keeping on top of what's coming from what system. And that's been the case. That was the case to start with. But AI is making this worse or more challenging. So historically, you've got your systems here, and then we're obviously talking in a very business context. On the left hand of the slide, I've got my SaaS platforms that are my Workdays, my SAPs, my LinkedIn, or whatever, that's generating data as part of our processes that we want to make use of. Obviously, the most valuable data comes out of systems that are actively gathering as part of their business as usual. And I want to get it to certain different target systems here, your ThoughtSpots or other reporting tools for my traditional BI purposes or my analysis. And a lot of the time it is still spent on maintenance. Very little is on value creation or like real insights coming out of these things. What happens with generative AI? Suddenly, it's a lot easier to generate an awful lot more data coming in on the left-hand side of the stack in a whole lot of different ways. Generative AI opens up needs to work with particularly unstructured formats, free text or semi-structured formats, or free text, video, audio, call recordings, all of those types of things. Lots of interesting and valuable information in there. And we can start to access them, but we've still got to wrangle them. I'll talk a little bit more about later on about this, but one of the most powerful things generative AI gives us is the ability to turn unstructured data into structured inputs. You can ask it to give you questions that are yes/no questions or categorical labels, or just to extract from a document the text that's relevant to a particular topic, get it into a format you can start working with. So lots more data being created that's valuable and you want to bring in. There's also a lot more demand for it because there's all these tools that are coming up that are, again, enabled by the generative AI phenomenon, enabled by the large language models, but they're hungry for data. They're pretty useless without the data or the contextual information. So this leads in the business problem we're addressing is there's a massive strain on the data teams, and most of them were already underwater with backlogs and people yelling at where's my updated sales report and why hasn't the new billing systems format been updated, or why do we have no feel for what the customers are complaining about. They were all underwater with that to start with, and now the AI revolution is just loading more and more onto them. So what's needed is a way for the companies to help scaling up to bring some machine scale, some automation to the previously very manual process of configuring, moving data, transforming data. Certainly that's the business problem we're addressing. So previously you had hand-coded data, you write your SQL, you have tool-assisted things, this is where we kind of started out by providing low-code platforms or things that start to make it a bit easier to manage that. You have agents starting to come in, so as you move into the world where we're at the minute with augmentation with the coding assistant, and longer term where we're moving towards is even more automated pieces where you're giving it a purely natural language instruction and having that build out in terms of the speed at which it delivers the data, gets it for you in the right shape. And a lot of that comes, or the right-hand column comes with being able to let a model operate over a complex tasks and giving it feedback so that it can push forward, rather than it just being an assistant to say, okay, what's the function I need here? What's the SQL I need to generate? As I said, this is a little bit, here's the word from our sponsor, this is our kind of commercial pitch. What do we mean without our solution when we say we've got an AI data engineer? Simplest view is I have multiple agents working with different types of tasks. I can give them a natural language instruction, the sort of thing you see on the left here, and I can have it through our platform, turn that out into something that can then become a means of moving and transforming data. So what we've got on the right-hand side is just a tiny screenshot, but really what I emphasize is because Matillion's core underlying platform is a low-code graphical interface for examining your data pipelines, the transformations that move them to bring two tables together, filter them, join them, aggregate them, perform calculations that may be more or less complex, or upstream of that, connections into source systems, connections to APIs. But all of these create graphical components you can put onto the pipeline, and that pipeline is something that's very easy to inspect. And part of Maya's power is it's very easy to examine its output and check its work. And we think that's the real way to embrace the agency. Constrain them in a way that it's very easy to validate they're doing what you ask them to do. Because if you can't test the output, it could be brilliantly productive, running at 100 miles an hour, in the wrong direction because you couldn't actually see where it's going or what it's doing. So I'm going to pause my slides and give you a bit of a demo of what that looks like in practice. And then once we've done the demo, we'll start to get into more what's going on underneath the hood. So I've got here some data. Actually, I'll start with this side. I've got a movie lens data set, which has got movie reviews, IMDb style stuff. I have done a little bit of pre-preparation. I've put it into a Google Sheets format. And you can see I've got some tags, there's comments about this, not quite sure what that is. I've got the actual rating that somebody's scored it against a movie ID. I've got a list of movies with some nice bits of mess in my data, some pipe separated columns. And I've got here a linking field. But I don't really have a lot of context about it. What I'm going to do, if I'm going to share this, I'm going to bring this, copy this link, because I'm going to want this link. I'm going to bring this into our UI. And this is our UI here. I'm going to say I've got a new task. So my chat window on the left-hand side is a default way of interacting with Maya. We're working on more ways. We're working on ways in which it get given tickets separately. But this is kind of the user interface. So I'm going to say, hi Maya, I want you to bring in the data from my Google Sheets here on movies. Work out, I say work out what's on the tabs. Tables and fit together. PS. I'm just going to say prefix tables this session with MSS demo. Okay, so I'll give it that instruction and start it working. What's going on while I'm working with that? It wants to do a plan, so that's quite cool. There's a loop going on. Master agent is a large language model processing instructions and being given a list of tools it has available. Those tools that it can operate. I'll try and expand some of this so you see some of the actions it's doing. It's asked me to switch to a plan mode, so come up with a plan before it executes any code. What will happen eventually is you'll start to see stuff appearing in the panel on the right-hand side as components are selected and it explores. But first of all, it's saying it needs to know the Google Sheets, the OAuth connection, and I'm going to say, it's asked me, it's come back to me with a question, it needs a decision from me as a user. I'm going to say, yeah, I've got an OAuth connection already. I've already brought some things in from Google in the past, so I've configured a connection. And it's taken a guess what my OAuth is here. I should be able to find that. And then, can you just tab names for you? I'm going to play dumb. Not sure what they are. Can you handle that? Actually, what you're starting to see here is the mode of operation that I'm doing is changing from being a hands-on developer to acting a little bit more the way a manager might talk to an individual contributor. You're delegating tasks and giving it advice and putting it in the right direction. You're completely hands-off in any way. So what's it said here? It wants a Google input, a Google Sheets input. It's registered. I want to give table prefixes, so I'll let it work away. But there's the levers that are being pulled with the tools here are the exact same things pretty much a human user would have. It's able to drill into the list of tables, components that are available. It's able to sample data in the same way a customer could sample data, which I'll show you in a minute. So here it's started to do it's created a component here. And this is one of our Google Sheets components. So you see we've got all the parameters here. Got the connections, Doesn't seem to see the right, it's complained about my connection, so let's see what I've got here. It's Google Sheets. It's just called Google. Okay, it was just called Google. Now, it's giving a validation error there, so it needs the component needs more data than Maya has been able to fill in so far. Hopefully now I've given it the right OAuth piece. It should now be able to start pulling that in and start to explore it. So it's now doing the equivalent of hitting the kind of drop-down buttons in that component to edit it. Underneath that pipeline, there is a YAML format that is defining the component and defining the parameters that are configured, and Maya is editing that. And you see here, it's found the tabs I've got available there. It's starting to make progress in terms of its work. All of this is stuff that's evolved over the course of basically 3 years of work. But what we're trying to get to is ways in which we're able to give it increasingly complex instructions and have less of this hands-on interaction. I'm getting quite a good summary here of what's in there. Still updating its to-dos, it's working away. In that piece, there's just this loop that keeps going of the core agent saying, okay, what do I need to do next? Well, I need to examine what sheets I've got to pull in. So that's then triggering a tool to allow it to query that drop-down. Then it's thinking, okay, I've got enough information now to say, fill in those sheets, and at that point, you can then, it can then call a tool to say, okay, well, what columns are available in those sheets? Sample the data the same way a human user would get. There's a continuous feedback loop going on. In some ways, what we're doing is a little more complex than the coding agents, the cursors, and Claude's this world, because the state of the database underneath is potentially moving and or being changed by what we do to it. It thinks it's got its stuff ready. You can see it's created connectors for my pipeline. I'm going to give it permission to run that. I can set that for either so the permissions you give it very much by what trust you have in the environment. You know, I'm working in a dev environment here. I'm fine for it to run stuff. I probably normally would build the code in a dev environment and then use our Git integrations to push it up into production. If I was working in a production environment, I might heavily restrict it from executing pipelines. And it successfully loaded the tables. So it's now trying to work out how to join them together. It should start assessing the columns that are available. One of the key things that we find really useful for it is by giving one of the tools that the agent can access the ability to sample data, the same way, again, a human user can sample data. That allows Maya to get feedback. So particularly if it's trying to figure out how to join two tables together, it'll build out a configuration to allow them to connect, like it's done here, and then allow it to see, is there any data downstream of the join? Has the join worked correctly? So I'm actually going to say, okay, I'm going to look at this join. I can inspect what it's bringing in. I've got a rather small screen here, so I'm juggling things here, but I can go in as a user and see what join condition it's put in. So it's very easy to understand what I've done. It's created a couple of left joins. I'm going to sample that data and check so I can see that it's correctly getting data through. Looks like that's valid. Maya's saying, I want to sample. Yeah, all right, you can sample. That's the thing. Some customers would not want it to sample because of the confidentiality of it. Without the ability to sample, it does make it considerably dumber. I'll be blunt. But that lets it test for things like maybe those joins were done wrong, and it's joined. Say I've joined on a customer product name, and on one side it was uppercase and the other it was lowercase. I've frequently seen Maya examine that and then get to a point where it goes, oh, there's no data coming through. What's going wrong? It must be the case insensitive. We're building along. Again, I need to move that out of the way and that out of the way of the event space. So again, it's starting to sample and seeing how many columns there are, how many rows there are, what have we got underneath. Again, it's doing a lot of examining the pipelines. So an enormous number of tasks going back and forth, but each individual task is probably relatively simple. There's not the ability for it to work through comes from the ability to use the same levers the user would. So here it's giving me a little mermaid diagram. LLMs are really good at doing mermaid diagrams. My top tip, if you want to be able to get them to do diagrams, allow it to write them, because a mermaid just has text-based format for what connects to what. So it showed me, okay, what am I going to do? I've got my loads, I've got my transform here as a diagram, showed how many rows. So let's have a look at what it's built, my transformation here. If I sample what I've got. Okay, my genres are still in this mess. I've also got an issue, I think, over here, which is my timestamps are weird. So let's see if it can work those out for me. Again, these are just the sort of things a human data engineer can do, but they're tasks that can happen at a speed much faster than most users will be able to do. We have done some bake-off competitions in the past, like Merck tried it with this, where they had two data engineers try and do the same task. One with Maya completed the task in half an hour, one without Maya took 10 hours to do the same exercise. So again, these are all the sorts of things that it's not massively complicated to do any individual step programmatically, but it's a huge time saver if you can give it these kind of instructions. So I'm going to say, can you work out what's going on with the timestamp odd, also split the genres into separate mappings. Do we need a new table? And pull date out from the film name. So like 3 separate instructions, 3 separate tasks there. Again, they're all pieces that you can do programmatically, but it's really handy to be able to give it that kind of instruction. If you can imagine, those are probably the sort of things that might take me half an hour to figure out how to do each of those little bits. What I really want to do here, I'm working towards kind of get like an average, like some average movie ratings by genre and get some views of that kind of analysis. So here it said, okay, timestamps, the unit equal seconds. Great, so that's working on there. Genres are pipe delimited, and the pattern there. So it's got a strategy for each of my tools here. Again, a lot of this is you taking advantage of the LLM's ability to read, both to look at what's in the sample and look at the format of the data, and then also using the tools, some of the tools that we're giving it is just definitions of what each of our components do. So to give a very simple, it's like we've got about 200 components. In the transformation space, there are all these things like joins, filters, ranks, calculated field calculations. It works out which of those tools are the best tool for the job. You can see it's starting to put calculations in here. A little bit there. So let's say I'm looking at, what's that, rating. So it's doing a simple 2 timestamp. Okay, we've got the right format for that. Let's have a sample and see what that's doing. So there it's turned that into a sensible date. What else have I done here? Split genres. Split genres, it's written a little bit of SQL for that because it's not got a trivial, we've not got a function that exactly on the nose does that to hand. We try and restrict from using too much SQL because we want it to use our low-code components and make it easy to understand. So here's my updated pipeline. So let's I'm going to say, actually, can I now get this into a star schema style format? So get it to transform it, get it to do fact and dimension tables into this view. Wants to make a plan. And all of this is going off of 4 relatively simple tables. There could be a lot more going on here. There could be a lot of repetitive actions I want to take to go through this. So here it's come up with a strategy here about factor ratings, genres as a bridge table, the tags. I'll let it go away with that, see what it comes out with. I'll let it run for a little bit more, and then I'll probably ask it to do some basic charting of like, okay, well, what's coming out of this in terms of the data, in terms of the trends. But again, all I'm doing here, is underneath the hood, filling in each of these pieces, these components that you could manually enter. As we're doing this today, we're driving this as a new user experience way of working on it, interacting with the software. Gradually, we'll probably move more to a system where you give it, as I say, tickets or tasks, and those might become recurrent task instructions, because I'm using this to build a star schema, but I could be using this to inspect data quality, like do some investigation of the data quality, and I might want to make that a scheduled task that I do basically every day or at the end of each load as a view. So here I've built up my various tags, built up my various ratings, it's got my split. Still not a horrible mess, it's reasonably understandable. Yeah, go ahead. Sorry?
Support large language model, and you like to do the same task, for example.
Yeah, that might help. Yeah.
I understand that you using large language model will support your work.
Yeah.
Building some pipeline for accepted data and accepted some result.
Yeah.
But I expect that then you could use several line of requirements from the large language model for the same aim, and how you could guarantee that someone who will use the same several sentences get the same result without.
So kind of how do we test, because this is the non-deterministic nature of the models, and how do I test that it's working the same way? I'm just going to give it its next instruction so it can be whirring away, and then I'll answer your question. So I'm going to say, okay, can you give me a summary now of which genres are most popular and trends in ratings. So I'll let that churn away for the last step of the demo. So testing this is, obviously, we have a non-deterministic system, and we want to validate that it performs the same way or approximately the same way each time. And of course, to test that means you can't just have a single unit test of a function. What we do instead is we use a system where we have 3 large language models working in concert. We have a set of I'm getting feedback there. I think yeah. Let me try that there. We have a set of test scenarios that we've written to say, I would like Maya to do this thing. I would like Maya to load data from this particular bucket. I would like Maya to transform the data to get me a report on what was our top performing region for sales last year. Or I would like Maya to build me a transformation like this, and tell me what the most popular genre was. Various different analytical scenarios or data movement scenarios, like how many rows of data are left in this view. And the three models that we use, we'll have one is a headless version of Maya, which is effectively an API that you can talk to. One is another LLM that is instructed to play the role of the tester and is told the instructions of what they're trying to achieve, but not the answer. And is told, like, try and get Maya to do this task, and at the end, sample and see how many rows you get back, or what the answer is, or each of those kind of views. And finally, the third model is a large language model that looks at the log the tester creates. So the tester creates a log to say, all right, I got Maya to build this thing, load my movie data, in the end, the most popular movie was this, and the most popular genre was that, writes that to a log, and then along with the whole conversation, and then the AI judge rates that log and says, okay, I can see this success criteria. I can see the most popular movie was supposed to be Toy Story and the most popular genre was supposed to be comedy. Has it got that right? Give me a yes or no flag. Did it get that answer that we expected? And that allows us to run the scenario multiple times because each test case, because of the non-deterministic nature, I can't just run it once. I've got to run it like 10 times or 50 times to make sure that it's doing it consistently. And we also have the judge, write out commentary on the failures about what the failure mode was. This is where we're getting more interesting stuff, which is, that's free text, and obviously you get a lot of those over different runs. And this is a technique we found that you could apply to a lot of free text pieces, which is we take those free text outputs, apply embeddings to encode them, and then use a k-means clustering to identify the clusters of types of messages that come back. So effectively, semantically, by seeing where they appear in the vector space, which ones are closest, we get the ones that are semantically most similar, and I go, okay, I've got 10 error messages over here, and they're all saying something around, didn't really seem to understand the question, or didn't give me the answer I was instructed, didn't build the right thing. And I've got another 20 over here out of my 100 runs, and they say, oh, well, the process broke down, the conversation went sideways between the two agents, the tables didn't get built, or Maya kind of stopped at some stage. And I might have another 5 saying, well, it gave an answer, but it gave the wrong answer. And I can then, that grouping lets us then summarize those error messages. But the core is fundamentally, we have the AI judge looking at the log, and we did calibration exercises, first of all, to make sure we trusted the AI judge was scoring reasonably accurately, or at least, and that we calibrate by saying, does the human analyst agree with the AI judge output at least as often as two human analysts agree with each other? That's actually a very relevant technique for a lot of stuff in this space. If you're scoring results, do you agree with the judge at least as much as you agree with another human? Because two humans will disagree in a small proportion of cases, or even a large proportion of cases. So that's kind of the threshold for success. That technique is quite relevant to a lot of cases. We found that, again, this is about constraining the outputs by asking a large language model a question where you say, don't give me any text, give me a yes or no, or give me a categorical output to like pick from a list. And that list can be, give me A, B, C, or D, and I'm giving you a multiple choice. Susanna on the top corner there is my team, did a great exercise a couple of years ago where we made large language models sit our professional certification exams, which are multiple choice tests. And it's really easy to mark a multiple choice test automatically because you're just saying pick A, B, C, or D, and then you can compare and score that. And that let us do a whole lot of score different models and also score the impact of using a vector database or impact of a knowledge graph. We did a little blog on it and saying, well, congratulations to these 3 Anthropic and these 2 OpenAI models for passing our certification. That actually showed us the real value of a knowledge graph, by the way, that without a vector database on the documentation, basically none of them could pass the exam because a lot of it was bespoke knowledge. The vector database over an encoded set of documentation got most of the frontier model at the time, bear in mind this is 2 years ago, up to a passing mark, which was 70% for a human. But if you added in a knowledge graph over the articles in our documentation, that raised the average percentage by about 10% and put it into the mid-80s. And the impact of that had come from the fact that quite often to answer a question, you needed a technical exam question. You needed not just the immediate closest semantic hit, but also a related article to understand how to use it. For example, we have a component called an iterator that basically says loop through a list or loop through all the rows in a table or similar, and use that as part of basically repeat this process for each of the lists. So that might be going through a list of table names to do something. You can't use an iterator without a variable. So you needed the variable article. You needed to understand, basically you need to have read the iterator documentation and the variable documentation to answer the question right. And what we found was, with the vector database, they all got that one wrong. If you added the knowledge graph, they all got that question. That showed us the power of knowledge graphs. But the core lesson I take away is if you can frame your testing into a multiple choice questionnaire, Then you can run it as many times as you want to spend the money for the credits to do the test. And as opposed to the human effort to mark the output is huge. So you're trying to constrain the output into something that is then programmatically validatable. Equally, if you're asking for a Boolean output, a yes or no, we can then apply all the traditional confusion matrix style scoring techniques and analysis, because I'm just marking a yes or no, and that's then really easy. Getting into the reasons it failed, you then get into the semantic clustering. But anyway, kind of showing where we're at with our results. So I've now got my tables here, my star schema. I'm able to get here what's it driven here. It's given me, can I expand you? It's given me a diagram of all my foreign keys between my tables and what's available. Summarize what's there, how many rows. I've then got, again, can I draw you out? I can't draw you out easily. And the charting, we've just given it access to one of the chart.js libraries to be able to read some simple views, total ratings and average ratings for the genres. Let's say, again, I could simply try and say here, give me histogram of ratings. Right? Our core offering here is very data engineering focused. Once you've got it into the right shape, we're not too bothered about the end part. We're starting to move downstream into the analytical space a little, but these are just to allow the data engineer to validate what's going on, that they're getting the right results. And again, here it's given me a nice chart here. Being able to talk to the charting libraries and just give instructions. So let me say, hey, no red, green splits. Some of my audience are colorblind. Please, for the love of God, if you work in this space, remember a large number of people are colorblind. It's a pet peeve, but there you go. So it's a little better, it's probably a bit more sensitive, but it's relabeled the colors there.
Can we see the top 10 films? I'm dying to know.
Yeah, which were the top 10. It's way, I think this is 90s based films based on these scores. Give me a pipeline. Work that out. So I haven't actually specified a scoring system because this is a rating. This is a 1 to 5 rating system. So let's see what it does and chug away there. And again, a little bit showing off. Part of the reason we're prepared to let it have this control is you see up here, I've got an integration with Git that lets me commit or roll back. So if it's gone too wild, I can roll it back. So it's building, count per movie, average rate. So it's going for a mean here, okay. But I could correct it. I could stop it and say, no, I want a different strategy. I want a scoring system or something similar. One of the other interesting things is, you'll see when it's come back to me, it's giving me a thumbs up, thumbs down. What we found in practice with our end users is basically nobody gives the explicit feedback. What's more useful, again worked out by my Susanna up there, is watching for people who hit the stop button, because that gets used about 50 times as much as anyone actually giving us a rating. So one of our lessons for trying to build these systems is look for the ways you can collect implicit feedback as part of the exhaust gases of the regular process, rather than waiting for people to give you ratings. It's a little bit, the explicit one is I could look at these by what people tell me their favorite movies are, because they're trying to impress me or look cool or erudite. And they say that they love Persian art house cinema and something in black and white. And actually, they've watched The Godfather 15 times, if I look at their implicit reviews. So here's our ratings, come back there in the genres. I'm going to leave my one last task to be working on while slides and talk a little bit more about what we've learned and how this is working. Okay, I need a presentation done out of this data on relative popularity of genres and how it trends over time. Use the charting and skills. We'll set that going, and then I'm going to go back to my slides while Maya works away in the background here. So slideshow. Okay, so I'll show you quite a lot about what's going on in the hood. It's a fairly lengthy demo, but what are we doing here? So we've got human intent to a variety of different types of tasks you might need to do within data engineering, whether that's configuring connectors. So one of the things we found very useful is being able to take an API's documentation and use that to configure one of our components that connects to other tools. The core data engineering tasks are the types you've seen here. Migration of pipeline scripts and similar from other platforms. The models are extremely polyglot. We found it's really useful for being able to say, okay, I've got a whole lot of legacy SQL scripts or Alteryx jobs or Informatica jobs or other pipelines. They're very good at taking code in another language, translating that to pseudocode to say, what is the intent of this? Possibly to extract unit tests from it or not, or just get the pseudocode, and then building it back up in our format. So if people want to migrate off some of the other platform, obviously commercially, we can do deals with people to say, are you spending a fortune on Alteryx? Would you like to come to us instead? We'll be cheaper. And we can, and they're relying on the fact it would be a 9-month or 12-month migration project to come off. And we can say, oh, with this kind of thing, Maya can understand what their job is doing, translate it to one of ours, convert that convert those in a matter of a few minutes per task instead of a week or two's human effort. So it becomes a very commercially appealing thing. Equally, you could go through legacy SQL and say, I think my SQL is inefficient and slow. Can you go through these and update them, try and make them more performant? Or just do something as trivial as, I've got 200 jobs that have accumulated over the years. I'd really like to go to a more consistent naming structure. Please just update them to be applied to that. Refactoring or similar, or just schema drift. Like new columns have come in. Can you wash this through all the pipelines that affect it? Lots of tasks that are somewhat humdrum, usually annoying to do. And that's, again, the big lesson for automation in the Gen AI space, which is look for the tasks that are boring and no one wants to do. Because they'll cooperate when you want to automate them, and the human isn't adding value. So they're your prime targets when looking for a project to apply these to. Again, a little bit of our architecture. You probably don't need to do too much of this. Matillion sits as a control plane over cloud data warehouses. So we're generating instructions to be passed down to Snowflake or Databricks Redshift to be executed. We provide a lot of the management layer of like scheduling things, looking at all the data ops tasks of like the whole Git stuff, the publishing pipelines through the CI/CD toolchain, and of course we provide a lot more security management, secrets management, all that kind of view. There's a little bit here at the top mentioned there called Context Engine. This is the coming soon piece. We've got the first steps of it. It's being tested by some of our private preview customers. Context is king when it comes to large language models. What you've seen here is a tool working away using its ability to manage our tools and do the technical side of the job. But that's only one half of the challenge. Writing the code is one part of it. The other is understanding the context of what's meant. There's a whole lot of things that a data team would need to unravel, which is, if I say, can you build me a report based on our sales orders? The model might need to pick out which is the right table. And that you could have 5,000 tables in a large organization's data warehouse. And of that, there's probably about 25 tables called something like sales or orders, or sales order underscore old, or sales order underscore new, or sales order underscore new underscore no really this time. And I need to pick them out from the ones that are sales orders underscore JW, which means that they're my scratch workings and they're not, that people should ignore them. So the first thing we're trying to do is we've built tooling to scrape the data warehouse, scrape the metadata, look at all the tables you've got available, sample the data, and just look at what's in each one and create a little summary of what's in each one, and we start to build that into a knowledge graph. That's the task of kind of entity detection, of going, okay, well, what concepts exist within this data? What types of things are there? What you've got in a commercial one might be very different in a finance one, be very different to a pharmaceutical piece or a research or a university's data warehouse, different types of data, different types of objects. But there's probably a similar structure of, okay, what are the entities? What are the top level concepts? What are their attributes? What are their properties within that? You also need to understand, okay, which columns are keys? How do they relate? So you build up that view, and we build that up into a graph, and a graph seems to be a very good format for it. We give Maya the ability to write queries to query that graph so that it can explore and go, okay, this concept is closely related to that table, or there's a lot of evidence to believe they connect. So starting with, we're looking at what's in the data warehouse. We're building in, looking at your execution history, because again, that tells a lot of patterns. The table that's in the job that runs every 10 minutes is far more likely to be up to date, and the one that hasn't been touched by anything that's been executed in the last 6 months is probably staying relevant. And that's a really useful, powerful piece. Again, I'm trying to look at the byproducts of a process that's active rather than waiting for people to do the data cataloging exercise, which will involve a lot of argument, a lot of debate, and then will be out of date almost the minute you stop doing the updates. And we're gradually bringing in, okay, well, how can I look at that conversation? You saw me having a chat with Maya. How can I extract from that what information tells me about, okay, what tables did the user ask for, what concepts? Did they give me any definitions? Did the finance user specify when they said revenue, they said 28-day consumption annual revenue is the one out of the 8 different versions they've got. The next challenge for that then moves on to understanding the user's relationship to that concept. And this is future stuff we're working on, but things like finance user says revenue, sales user says revenue. Finance user is probably thinking of net revenue, like what's the actual money we're making from this. Sales user is probably, by default, if they don't specify the concept, thinking of gross revenue, because this is how much I brought in, me the big hunter, go get big deal. Sorry, I'm maligning my sales colleagues there, but their default definition of a high context term for the same word might be different between 2 people in the same company or same bigger organization based on the groups they're at. And those are all challenges we're trying to wrangle. The aim of this is to start to extract tribal knowledge out of the organization, because at the minute you've got all the gotchas, include the fact that someone who's been your Salesforce admin for 20 years remembers that last year I added these 3 columns to the account table, which means, of course, that for any new account that they're populated, but for any account that's older than 2 years, those columns are going to be blank. And that's probably quite relevant when you're doing analysis, like, oh, I'm doing a segmentation of this by industry. But yeah, my industry's blank for all my old customers. I should remember that. That's probably going to affect my numbers. So there's a lot of stuff we're trying to do there around collecting that context, and that's our big focus right now. What does some of this mean for businesses? So here's how people are using. I've talked about migrating from legacy platforms or moving things from one to another. Human augmentation, so just helping people scale up, helping people get on top of this. As we say, every data engineering team we know of in the world is overloaded and has more than they can possibly get through with their backlog. Nobody's saying, oh, we're bored now, I've got nothing to do, I'm worried that I don't justify my existence. Just helping them speed up is great. And then, as I touched on at the start, AI, getting data ready for AI projects needs working with all sorts of types we've not done before. Getting used to working with unstructured data, which the data engineers are not really used to at the minute. We're just starting to get our hands around, and they need assistance to be able to make that work. Some of our case studies and the outcomes, as I said, Merck did a bake-off. Several of the others have driven some really massive savings in terms of just how long certain tasks take. This is not the whole of a data engineer's job, but pipeline building is a significant part. Being able to do it fast has a big impact. The St. James's Place one is quite an interesting one, actually, because it reflects a different way of using questions. What they were doing was using are components that let you use large language model within a data pipeline to ask questions about each row of a survey that was coming through. So they had thousands of customer surveys. The Financial Services Authority required them to take a survey by law of their customers. And these are free text surveys, usually about a page or two of text. Processing this is the most boring task laid on the most unfortunate interns sitting around that company. And it's very slow and it's extremely labor intensive. What we figured out you could do is take a subset of those, get the themes that are, deduplicate that list down to about 20 themes. And those themes would be things like investment performance, the support portal, the fees structure, the quality of the advice they were getting, the relationship with their advisor. And then you can go through each survey and say, just yes or no, for each of these 20 questions, was that topic mentioned in this text? And then filtering based on that, for if yes, what did this survey say about that topic? And this, by the way, you can do this with our tooling, you could do this with Python. I'm not going to make some claim you need to pay Matillion a fortune to use this technique, but we make it a lot easier. And that then means I've extracted the text relevant to each topic, and then I can do a sentiment score, again, sentiment models are pretty well established now, on each subtopic. So instead of it being this person gave a 7 out of 10 because it's mixed feedback, they grumbled about some things, they liked some things, actually what I've got is they gave a 9 out of 10 for the quality of investment advice or the quality of investment performance. They gave an 8 out of 10 for the support portal, and they gave a 2 out of 10 for the fees structure, which says you've got a customer that is happy with the financial product, they'd just like to pay less money for it, please, which would be very different to that being the other way around. There's other scenarios in which a lot of interesting scenarios you can do, but that kind of create a definition that basically a common sense person, we call it the infinite intern. If I could give the intern a set of instructions, if they're really to say, read this, see if this criteria applies, give me a judgment call. The models are great at doing that, and that's a great way to create new data into a structured format you can work with out of unstructured stuff, whether it's transcripts, whether it's text-based stuff. And of course, it doesn't have to be news things. This could be surveys from the last 50 years. Anything that's in free text. I was going to talk about this in a later slide, but different story in that scenario was use case was a firm working in the pharmaceutical space or healthcare space. They were creating an app for doing patient diaries. The idea was either be used by support groups or for clinical trials, and that the user would each day record a voice note about how they were feeling, their symptoms, and the like. And what we worked out how to do was, okay, you can connect into the transcription services, and we've got a connector for AWS Transcribe to turn that to text, and then use that yes-no question technique to say, yes or no, did this person mention taking their medication today? Yes or no, did they mention loss of appetite as a symptom, anything indicating loss of appetite as a symptom? Did they mention feeling down or depressed or anything that indicates mental health issues? It has two powers doing that. One is leading the witness. If I give you a structured survey to please say yes, maybe even if you didn't take it. But if I wait for you to see if you volunteer it, that's a different question. I'm more likely to get a truer picture. Secondly, and more powerful, I can go back with fresh questions that might arise during my study or my investigation. I don't have to relaunch my survey and start again with my data collection. So let's say halfway through a clinical trial, I think that nausea is a side effect of one of my medications. All right, well, I go back to all my transcripts with an extra question saying yes or no, anything indicating the patient felt nauseous here. And equally, I can mine historical data for that. And I can keep looping with different phrases of the questions, but I'm getting nice Boolean data out of it that I can report on, I can filter on, I can do a different follow-up, or I could turn into an eye on it, or I could turn it into an input to a classical machine learning model. I could do feature engineering with it. So there's a lot of capacity in that space. Slightly different space to Maya, but really useful areas. Okay, so why is Maya working so well? You saw it's pretty effective there in terms of its demo. A little bit of history. We got in the space early, I admit, back in 2023 when we first started experiments. The YAML format that defines those pipelines it's a proprietary format. It's never been talked about outside of Matillion. We assumed when we tried the experiments in early 2023 that the models would crash and burn on our proprietary language that no one had ever explained. Actually, they did pretty good because we built it, or I say we, my predecessors, built it to be human readable. And that combined with some basic documentation was more than enough to explain what it did. So the first experiments were just, okay, read this definition and tell me what this thing does. Generate notes, generate documentation. We spent about a year and a bit with what we had called Copilot, which is where it was doing simple edits, but it didn't have the ability to sample and get feedback. So it made for a lovely demo. It was a nice party piece, but it wasn't actually that much faster than somebody doing configuration by hand if they're an experienced user. What really revolutionized it was as we got into early 2024, we figured out, early 2025, we figured out how to give it the ability to sample, to be able to look at the sample the data and view what's coming in, and that feedback really supercharged it in terms of the complexity of task it could handle. And this is what I call making it think inside the box. So this is the core agentic loop. So there's a whole lot of user starts with a message, and the agent starts this loop process where it thinks about what tools it needs and those tools are things like edit a file, view a file, sample the data, and look for validation errors. And it will keep looping around until it thinks it's completed the task. And that ability to sample, that ability to get errors out of the UI is the power that lets it go a lot further in those loops before it stops and says, I'm stuck, I need guidance. Similarly, the other advantage we have is because we're a low-code environment, it's very easy to expect the outcome. So you can quickly write a lot of SQL, but that will quickly become uncontrollable or hard to manage, whereas we've got a graphical way to make it very easy to inspect, so the humans can build more trust in what we built. But as I said, the real power is constraining this. So we're mapping them to binary formats. It makes it very easy to measure if they built the right things. I think I've covered most of the stuff on this slide already. But that constraint is, we're trying to get it to fill in the form. So the yes, what would be the yes or no on that unstructured data here is, okay, your options for filling in this parameter on this one of our components is one of the list of 4 things. You've only got to pick from 4 things, and I can mark that a lot more easily than you writing unstructured code. All of that lets them quickly validate, you've picked something that's not on the allowable list. Is a really powerful lever to get data back into the system and say, try again, you were nearly there, you didn't quite pick the right one, try again out of this list. And that kind of view here is, as I said, the fact it can keep trying, seeing what the data looks like, inspecting the data, lets it explore and therefore work on much more complex instructions. So the earlier days, the instructions were add these 2 tables and join them together. Now group by this column and aggregate the sum that column. Now add a filter. Now write it out to a new table. Instead, it's get me a sales report for this region summed by month, all as one thing, and it can build far more complex tasks and far more complex, go a lot further. And that's what's moving it to rather than it being just a coding assistant that's helping you complete the next line, it's taking a ticket from you effectively and developing that ticket. What have we got here? So this is actually pulled out, Isaac and my team, he's looked at the different tools that are called. So we're starting to see that the cycles that are processing here. So the first piece is probably the labels are going to be tiny or hidden on the bottom corner here, but the light blue is delegation. So this is the agent, the top level agent kicking off sub agents with things it needs to know. The blue stuff is discovery. It's exploring what's there. It's seeing what's in the pipeline, seeing what's in the database. What have we got here? Yellow is when it thought it needs a design phase. The greens, and again, I've broken my own rules here, but the greens are it building. The reds are validation or getting feedback and coming back and forth. And it's that cycle that lets it do much more complicated tasks and go much further. And we can measure these and we can start to look for failure patterns and look for where it gets stuck. And a lot of our stuff here is now trying to understand exactly what our users are doing with it each time and understanding these views. But these kind of steps let us see how effectively it's using the tools and is it getting stuck in a loop? Is it doing a very complex task? Again, the human is starting to become more of a leader giving tasks where it's going off to work like an individual contributor for them rather than doing the tasks themselves. So quite a lot going on there. We covered the test harness when you asked the question already, I think. I think we covered all of these pieces about the test framework. Other big lesson, large language models are extremely polyglot. And it's true in two senses of the word. We've talked about them being able to understand other coding languages. They're really good at that, and really good at translating. They're also really good at other human languages. I discovered, and I'm quite proud that I discovered before my French colleagues, that you could talk to Maya in French and it would work perfectly well. Yeah, Dave, Gwendole's really annoyed you by that first. And it's actually a really powerful tool because, even if people are working in corporations where their first language is English, quite a lot of those folks, English is not the business language is English, but English is not the first language of all the employees. So being able to say, you can talk in German or French or whatever, and we've got a significant community using it Japanese, and their feedback is it speaks perfectly good Japanese and very well, and it's localized our product without us having localized any of the rest of the UI, which has been a really powerful piece. And also the use of it within the pipeline to transform data works just the same way. Like I've got a whole lot of job titles, I want to standardize them, it will immediately translate those that are in different languages for you. It's a wonderful, wonderful tool for that kind of piece. Our other big lesson, and this is takeaways, this is in the learnings, what we learned is, if it half works now, don't throw it away. The field is moving so fast. If you can get a POC that sort of works for the happy path, it's not really robust to the unhappy path yet, be patient with it. Maybe park that for 3 months or 6 months and come back to work on something else, come back to it. A lot of people are spending an awful lot of money to solve that problem for you by making the model smarter and creating additional tooling around it. So be prepared to say, all right, well, let's leave this one for a little bit and come back to it. Don't let it get to the point where the organization has rated something as a failure. When we started those early Copilot pieces, we were firing 5 parallel queries to the model and taking the first one that came back in a valid JSON format, because quite often it would get lost along the way and be malformed at the end and lose a few closing brackets. Now that's not a problem at all. We don't need to do that because the models have advanced so fast. So just be prepared to say, okay, looks like it's kind of working. It's not reliable enough now. Agree my criteria for it being reliable enough later, and kind of check back in on it. So I also promised to talk to you a little about how AI changes teams. I've got about 3 or 4 more slides just to set expectations on time. This is a model my former boss and I designed long before the Gen AI days. We call it the double helix model. And the model relates to the matching of work with the matching of the complexity of work with the skill of the person. It's usually what applies to technical context. Our theory was that you need to think about the impact of the work on the employee or the team member as much as you think about the impact of the team member on the work. With any technical task, you kind of want to match them up. So if you think of the red spiral is how complex the work is, and the blue spiral is how skilled the person is in this space. And you want where they cross is a nice perfect point, because where they cross it's within the person's capability to do it. They have the capacity to learn it. It's not trivially beneath them. It's not so far above them. It's impossible. So that with a new technical task, let's say thing that the team's never done before, I'd probably give it to the technical lead, right? You give it to the most experienced person. It's a challenge for them. It's interesting. But the best technical leads generally are hungry for really challenging work. So I give it to them. It's a learning experience. It's probably quite tricky. They'll learn some stuff from it. They'll make some notes on it. So the second time around, you've got a bit of learning about how to do this more easily. Second time comes around, you probably give it to the same person. Okay, they've done it at least once before, but it's still fairly uncharted territory for us. It'll be a bit easier because the task complexity has shrunk because you've done it at least once before. And that person has grown a bit because they've done it at least once before. Third time around, maybe you start to think, oh, maybe, actually, it's a bit boring for my top end, my best principal engineer to do it. I'm going to move it down to a senior dev. It'll be a learning experience for them. They'll get a bit of coaching from the technical lead who did it last time, but it's a growth opportunity for them, and the task's becoming simpler and simpler because because you've learned it as a team. You've probably got a procedure now. You've got some notes. You've got a bunch of previous tickets you can look at for how it's been done. And eventually it goes down the stack right into the point where it's trivial for most of the team, but it's a learning task that gets handed to the first intern, the new intern who joined last week as practice for them. And that was true. We regard this as a philosophy for like how you grow a team and how people aspire. But it's a good metaphor for how AI impacts a team. What's happened with AI, the coding assistants and Maya on a data engineering team is everybody's been lifted in terms of the technical capabilities that they can handle. So the tasks have basically all moved down the stack. The technical lead is now either working at a speed never before imagined compared to where they were 2 years ago, or working on stuff even they didn't think they could do. The senior engineer is doing what was previously, oh gosh, only the technical lead could do this. The junior engineer is doing far more complex stuff, things that would now, the person fresh out of college is now doing the thing that might have been a 2-year experience of engineer to do. And I've gone down that. And the stuff that previously were tasked for the new graduates, the interns or similar, actually your business users, your totally non-technical people find it accessible. So everybody's moved up. You haven't really turfed any one individual, you haven't discarded any one role, but the speed at which you can move and the scale at which you can operate has changed. Everyone's moved up that stack. And the analogy, well, the story I give with this, which is looking at the impact in terms of work. I was talking about this with my father last month, and he was explaining how back in the 60s, in his first job as a nuclear engineer, he was working out how much uranium to put in a nuclear experimental reactor with a slide rule, which is a slow task because you really wanted to get that number right. And anyone that's ever actually used the slide rule, we know it's quite easy to put the decimal point in the wrong place, which could be very bad in the scale of bad things in that operation. Calculators came along and made that job a lot easier. Didn't replace the need for someone very skilled to work out how much uranium to put in, but the calculations took an hour rather than a day, that kind of thing. It's just changing that scale. And I think that's a good mindset for how the AI is changing teams. It's not eliminated any individual role, but, you know.
Additional question. How change the security in working with data?
Okay, so security is a very interesting one. So that's the piece we have here is in terms of we have a lot of data sovereignty questions about where the data goes. Obviously, Maya has to be able to sample the data to work with it. There's a big difference between am I using if I'm using a free, openly available LLM, obviously my data's going anywhere and can be trained. You wouldn't want to touch that. Pretty much all the commercial providers or anyone under enterprise agreements, terms and conditions will mean they should not be training or touching that data. The data is, however, it's going to wherever that model is being hosted. So we would, in our scenario, we're working with AWS hosted models via Bedrock, via their frameworks. And this is an interesting one because people you might perceive that as a big security risk, but it's no different to data to a model that's hosted in Frankfurt, say, is actually on the same level of security as I'm putting data in an S3 bucket that is hosted in Frankfurt, or I'm moving it to a EC2 instance that's running my Jupyter server in that Frankfurt piece. I think there's this perception, I think there's more of a perception of danger with LLMs than there is. It's a case of where, if there models are allowed to train on it, then that's a huge security risk and you don't want that. If the models are being run in a framework where they're not training on it, then it's a concern, but it's just the same kind of concern that you have for the rest of your infrastructure estate. We could see this going towards a run your own model view in the longer term. We're wary of allowing people to do a bring your own model if it's a different model at the moment, because in our scenario, our prompts are trained for a particular model set. We're using the Anthropic ones currently. We adjust it all the time. If everybody brought their own different models, performance would probably be horrible for the models in different families. That actually reminds me of another lesson I will share that was hard learned on the evaluation space. The models are a bit partial to their own family's judgment. So if you're scoring an AI judge, you're setting AI judges, you'll find they mark their own family very sympathetically. It's a little bit like the Olympics in the scoring judges and that sort of thing. So a panel of judges, if you want to be really neutral, is useful. But yeah, so I think that's the big case. Like, where is it going? But it's no different to any other cloud service. I think it's like, where is it hosted? Where do you care? How is it transferred? The other part is, we're managing things so the model doesn't ever see any key. We're using a secrets manager, just the same way we'd make sure you give people access to the keys without the data engineers copying and pasting them all over or putting them in code. So yes, it's a challenge, it's a concern. We believe we're making it safer than writing raw scripts. If that kind of helps. I'm going to move on to my last slide, and then we're going to open up for some questions. Yeah. So how has our team changed as part of doing this? So what's worked for us? What's different? A whole lot of different things have happened. These are kind of some of, I think, Matillion's keys to success, what's taken us here. We have quite close engagement with the University of Manchester. We actually employ a couple of the professors from the database department as consultants. We pay close attention to our academic papers coming out of space. Actually, that's where my advice is that's where the universities are often the most helpful, which is just giving you the vocabulary by which concepts are being described in academia compared to industry. So this is a thing we're trying to do or a problem we're trying to solve. For example, with our knowledge graphs, we're talking about, okay, how do we handle, I've created one knowledge graph by scraping my database. I've created another knowledge graph by reading this wiki, that's the documentation. I now need to merge them together and say, is this entity node the same as that entity node? Is it the same concept? And they said, well, that's either node alignment or node fusion. And being just armed with that vocabulary, let us then search for a whole lot of research and get into the right space. So it's a great way to use the university resources just to translate for you. Again, a well-established tradition set up by a very wise man was to make sure that the engineering team's got a day's hack day every month, which allows them, even those not working directly on LLMs, to experiment, and that's had a lot of value. Keeping an eye on the blogs. What we call dog fooding the own product, using it ourselves, using it internally, gets a lot of feedback and gets a lot of response and gives you a lot of sniff test for is it actually doing what you want. Top of the middle, the second column, assemble diverse teams for diverse mindsets. I'm a big champion of diversity in recruitment. I purposely recruit through different paths. I've gone a long way out of my way to make sure, I'm quite proud to say I've got a majority female team. We've done a lot of research on how you word job adverts to make them more appealing to less represented groups. The core is, if you haven't recruited a diverse team, if you've got a homogeneous team, they will probably move faster because there'll be less friction. But there's a good chance they're moving faster in the wrong direction because they haven't got a diverse viewpoint. They haven't been pointed out that you've, that you may have made assumptions or may have missed things in the way the models are performing. And I think it's an important factor, particularly for anyone in the AI space. We put the software engineers and data science, software devs and data science in the same team, working on the same backlogs. We've had to learn how each other's ways of working, but it's important. We have a lot of that kind of, the data science team does a lot of the research, proof of concept, then a much closer handoff to the devs. The POCs are things they can then turn into production code. The coding agents are proving quite useful for this. Let you quickly translate. I've got a working Python script. Someone wants to turn that into Java. It's actually a lot easier to do. It doesn't have to be built from scratch. I won't go through all of these. I would mention that good documentation is really powerful for both humans and AI. When we first built pipelines to answer support cases, one of the things we found was the ones where the model's answer had been rated as poor, we could often map back to ambiguous documentation. Literally in one case, we got one answer where the agent had said, no, the model's giving me bad advice here. We looked back to the knowledge base article the LM had seen as part of RAG. 4 people on the call, 2 people say, I think the model's right, I've read the article, you can do the thing. You can move an Excel file back into SharePoint with a connector. And 2 people on the call said, no, the model's wrong, you can't move an Excel. Turned out the model was wrong. But what it had shown was our knowledge base article was so ambiguous, 50% of the humans read it wrong. And what's happening in that process is the support agents are now spending less time on in ITIL terms, so less time on incident management, actually answering the individual case, but more time on knowledge management, making sure the knowledge base is up to date, because the more accurate your knowledge base is, the higher percentage of the time the support model will get it right and handle it automatically, and less need for them to intervene. So it creates a virtuous cycle of freeing them up to give them more time to improve the knowledge base and look at change management and the rest of it. Our other factor was selling our successes. And finally, getting everybody hands-on. So getting the exec team, actually getting the exec team and the sales team to get hands-on with it and try it was a real revelation, because we've been telling them how easy it makes it, but actually seeing that when even the legal team and the our events sales manager and similar, where I would say, yes, I can do it. There was a degree of technical person tells me thing is easy. I'll believe them, but I don't do it myself too. I've done it myself, and then I've kind of got to it. Okay, I'm going to let's cut back to see how, oh, not that, not you. Come back to this, come out of here, I'll bring this back. Just see how it's done in terms of my view. It may well have stopped asking permission. Oh, it stopped at planning mode, so I'm going to leave that there. I'm not going to give you that. And I will just put this back to, oh, I did have a funnel. My other bits of advice, above all, please just try it if you've got hundreds in space. Nothing but getting your hands on. A lot of this has come out of experimentation, like the language stuff. We didn't realise, well, let's try it with some French, see how it does. And don't wait for people to teach you, because the space is moving so fast. If you've got a good idea, give it a try. So thank you, I hope it was interesting. Cool. Like I said, check out Maya.ai if you want to learn more, or the QR code will take you there. And I guess we'll to Adrian and others for questions.
Many thanks indeed, Julian. Very interesting take on, your sort of journey and the sort of environment that you've actually created. I'll ask the first question and maybe wander around with the microphone and see if people want to answer. One of the things that is in my mind was clearly there's been a lot of knowledge and communication.
The view there. We can see the general agents will gradually grow over time, but I think obviously the open claw style view is an extreme measure of letting the models run riot with everything it can do from a PC. So I suspect a whole lot of guardrails are needed before that true model is trustworthy. I saw a particular LinkedIn thread of I think it was one of the Microsoft around it saying, running back to my model before it deleted all my laptop before it deleted all my mails, because I could see what it was doing for my phone and I couldn't stop it. So it's what level of security versus power, but I think the specialization is an important piece. I hope that, yeah.
Any more questions?
So when you shield users from the complexity of nation, does that mean that you're rendering traditional skills redundant?
Let's see. It's been a trend in IT from the last 5 or 6 decades or more that the model, the programming languages and the interaction modes have become more abstract and higher level. So if you compare, machine language to assembler to C to Java to then we're probably all as data folks used to working with SQL and particular and like Python and R, which are way higher level than those languages. And I'm sure there's probably plenty of people who think I'm a terrible person because I write in Python and I don't have the skills needed to write in machine language. I think we're moving up one level there. I'd say that it's pushing people more into thinking about what is it you're trying to achieve, and the understanding and the domain knowledge is more valuable. What we do, obviously, yes, we're abstracting a lot of it, but it's still inspectable. So if I was to go back into that UI, I could turn everything back into the SQL that's going to be executed underneath the hood. So it's the equivalent of the driver in the car versus it's still available to inspect the mechanics if you want. The question is how often or how many people go into or how many people need to. If the car is more reliable, people tend to have less mechanic skills because you don't need to have the bonnet up that often. But it's still there. I wouldn't, and that inspectability of what's being done, we think is an important and powerful selling point. We look at it as the glass box versus the black box.
Does Mia interact with a particular LLM? Does he interact with multiple LLMs? Does he interact with cloud? Because you talked about the LLM, but which specific LLM?
Okay, yeah. So depending on the tool in that agentic flow, it's slightly different model. We're using all the Claude family. We use Opus 4.6 for the general purpose coordination and for most of the heavy thinking processing. For the lighter pieces, like searching through the documentation to determine which components are relevant, we might use a really lightweight one like Haiku, Sonnet. So we use a range of that family based on the complexity of the task. and that mix will probably be continually shifting. We do periodically, we want to look at other models and evaluate. It'd probably be quite a heavy lift to shift to a non-Claude family, just in terms of we need to refactor a lot of the prompts, but it's something we consider and looking at, and we kind of keep evaluating.
So that's like the first step of getting the context of the prompts.
Yeah.
And then so while it's getting the context, is also trying to get the LLMs to use. So that's saying like based on the context of the prompts. Yeah, so the prompt stuff side of things, you have multiple layers of prompts. So you have the core system prompts, which is explaining what to do, and they're effectively baked into the code, and they're telling it, they're the things saying, you are Maya, you are working as a data engineer, you have these tools available to you, and those are the bits we need to best to work with the models. You then have what we provide context, let the users configure context files, which are notes that sit within that file structure. So alongside your data pipelines, you might have some text fields that are just notes explaining the basics of what's going on here. So even without the knowledge layer stuff with graphs explaining pieces, this could be as simple as a few bullet points saying, okay, raw bronze tables go in this schema name, silver tables should be in this schema, output gold tables to be for reporting in this schema, here's my naming conventions, here's a couple of notes on the key things. That can provide a lot of useful grounding. A very interesting story we had there was that we were demoing to an insurance customer, and they said, oh wow, Maya's really smart, knows all our insurance acronyms the way Claude and OpenAI don't. And that just comes to the fact that we created a context file that was broadly said, you're talking to Mr. John Smith, who works for this company, this insurance company, here's the names of the tables that are dummy data. And simply by saying you're working for an insurance company, helped it ground it and say, oh, okay, I've got to use the insurance interpretation of that acronym rather than the one from pharmaceuticals or the one from physics or whatever. So small amounts of information can be very, very powerful for that. And then finally, there's the user prompt, which is what's typed in, which obviously is completely in their control to configure. Yeah, so with that, there's several places you can put the security. One is obviously that you want to secure the levers it's got available to pull, first of all. And the most obvious thing here is to make sure that you've not actually built too much pieces for outbound data egress. The second is obviously making sure that the user's only seeing access to what that user should see. So the credentials they have available is one piece. It is a real risk, and we have guardrails on the models trying to inspect for malicious code. The challenge is, this is a system designed to move data around. So yes, there is potentially, you could have vulnerabilities for prompt injection for, I'm reading the API configuration instructions, I've got something hidden in there that's trying to get it to connect elsewhere. Mostly we look for the Bedrock guardrails. We have stuff in there to kind of inspect is this complying with the user's instructions. It's going to be a continual battlefield. Security already is, or it always is, I think, is that phase. The last phase actually is what we'd normally advise customers to do is to use Maya in your dev environment, and then the pipelines, once you've inspected and approved the pipelines it creates, to promote them into production. That's their kind of ultimate security guide. Okay, so depending on the scenario in which they're being used,
obviously, when you're calling LLMs via APIs, which all these things are doing, they're providing you back with metadata about the call, the duration, when it came, and the number of tokens in and out, and similar. So for those that were, for the usage of Maya, obviously we're collecting, all the time we're collecting, okay, when did the message go, how many tokens were in it, when did we get an answer back, how many tokens came back in the response, what were the pattern of tool calls underneath. And part of that then feeds into, so for our usage, because at the moment you pay us for license the software and we're paying for the tokens. So we're trying to understand what people are doing with it, how much they're using it, how complex the tasks they're trying to do are. And equally, that test framework I showed earlier, in addition to looking at success failure, we look at how many tokens were consumed and how long each task took. And that we use that to measure in terms of optimization. That's a space we explore. With people using AI to transform things within a pipeline, the yes/no question stuff, components designed to configure those connections will also bring back that metadata. So it's quite a good way to use one of our pipelines to say, okay, I'm going to try the same question with 5 different LLMs, see which ones get the best hit rate and see how much each one costs me, and then I'm going to apply that, the most successful one at scale, to my thousands of rows of data. Am I answering on the right lines, or you not? But yeah, it's part of the stuff we're trying to optimize for within our test beds. And again, that is a space where we need to run the test scenarios multiple times because it's not always going to cost the same number of tokens to answer the same question. Cool. Any more? Go back. Let's see what we do for time.
Yeah. I do think this project could be improved by each agent in the pipeline. You can either right click and you can either right click, and it takes too much time to just type the AI right into the AI, right? So you can either right click onto that and generate the report, and it will literally generate automatically instead.
So I'm trying to, I didn't fully hear the question, so.
Actually, the problem is when you type into the AI,
Yeah.
it will take too much time.
Yeah.
Yeah, okay. So you can literally choose the agent where it generates and right click it and choose the list of it and set the risk and literally print out that action.
I mean, you're within a graphical UI that you can drag and drop pieces and drive that way. So you can tag back and forth typing to human interaction if you want to quite easily. So that those parameters, or if I want to change those joins to be inner joins, and I know exactly what I want to do for that bit, I can happily go back into that graphical piece, because the UI is designed for a human user first of all, and we're giving it a different interaction. So you can say, Maya, build me these pipelines. Maya builds you 5 or 6. You look at them, you see a couple of things you want to change them by clicking and dragging or what have you.
Yeah.
Or equally, it could be you're building it manually, and then you go, oh, I'm stuck here. Maya, can you help me out? Can you help me debug this? Or it could be, I've built one manually. Now I need to replicate 4 more like this for my similar tables. And then you hand off back to Maya. So you can tag back and forth. Okay.
That could be an idea. Also, you can literally decide whether you type it or generate it automatically using that agent.
I mean, the instruction or the intent come from somewhere. What we are looking at is views, what we call mission control, that we're working on, where we create ticket, we allow it to talk to Jira or similar and pick up tickets from that are instructions of the task you want it to perform. So it becomes more like picking up the ticket rather than the building the individual code. And that might be stuff where you do on a scheduled basis. So you might want to say, okay, I want you to go and inspect this data on a regular basis, or go look into the bucket, see what's there, pick it up and get it in, and give me a summary of the quality of the data. And that becomes a recurring task.
Yeah, actually, it is there was a tool called Multi. It is quite like that.
I'm not familiar with it, I'm afraid. So maybe catch me after, but it sounds like you're not. Yeah.
And also going back to code control and emo control, which we were talking about last week. There's a question of, I guess, layer as an example of this, where those models themselves become commoditized.
Yeah.
And the value from these tools is actually coming from people like yourself, who are putting the expertise, the context, and helping to refine models and the process.
Yeah.
Do you think that's likely to be the way that more and more of this AI work goes, where it ends up with some very specialised companies in the back end refining large-scale LLMs?
Yeah.
And then people distilling, if you like, the specialised.
Yeah, I mean, we've not gone into model distillation. We might over time. Potentially, it's one area. We certainly the discussion has basically come up pretty much every 3 to 6 months about do we want to get into fine tuning, and our answer has always been, well, actually we're getting the general models plus the structure we put around it in terms of context, prompts, and tools are doing more than a good enough job. And our direction of research at the moment is far more about the context engine pieces that was touched on, the knowledge layer about how do I capture the background information and the user, and to better understand the user's intent is the space where we see room for growth more than the small number of times it might misconfigure one of those components. Potentially the environment might change in terms of pricing, and then we might be into a distillation phase. But I think we always looked at it going, well, fine tuning is going to be a lot of work, a lot of time, a lot of cost, and you just might get ahead of the frontier model for your specialized task for a month or two, and then someone's going to bring out another one that's better anyway, and it can do everything else and tap dance and sing as well as do your little thing. So we've worked with the principle. Generally, the frontier model's been good enough, and I think what we'll actually find is that given the rate they're progressing, the Sonnet and Opus have been good enough for us now. So imagine in 2 years' time, yes, there's way smarter ones out there. So actually, models that are a year or two old will be fine for the vast majority of the tasks we're doing. We don't need to keep following the furthest advanced pieces, because we reach a point where we don't need that level of increased processing or thinking. Or possibly we're offering a range, like how fast do you want it to work? Do you need response in seconds? Are you happy leaving it churning for a few minutes? That's going to be. But yeah, my advice is the value seems to be more around the context, the levers you give it, and the structure you put around it, than desperately trying to tune your own model. Cool.
I think we've got time for one last question.
Yeah.
Getting to the end of the allotted time.
Hi, sorry. I'll just ask so I'm from the box and obviously if you actual thinking of against the vehicle, it becomes pretty expensive. So in terms of obviously a language you said using the code problem.
Yeah.
But I'm wondering, is there an option to if we have the infrastructure on premise, is it possible to use any open source models like Wiffen, for example?
Yeah.
Because at the end of the day, this is custom instructions and promises, so is that possible?
It's not something we offer today. It's something certainly happily pleased to feel free to reach out to us or connect and talk about specifics. It's one where we're kind of considering what that would be. As I touched on, we think there's a problem that bring your own model means that a lot of our prompts won't work in the same way, it won't perform in the same way. But it's something we could explore for the future, like how could Quen be the engine or similar? Particularly if you're paying to host a model, then it's an interesting piece. So maybe catch up with us after and we can chat. What I was going to say is we'll be around for if we want to grab another drink or similar, and we'll chat for a little bit. I'm happy to take questions, or people are welcome to reach out to me on LinkedIn, and I'll happily take follow-ups there if you've got specific pieces. Or, of course, register on the site if we've wetted your appetite that you want to talk to our sales team. That would be lovely, of course. But anyway, thank you for your time and patience, and thank you for coming and listening.
Just on the study group of the Statistical Society, many thanks for a very useful lecture, and responding to all the amazing questions that we got as well.
Right. Thank you. Yeah, and as I say, if anyone wants to drink a drink, you're welcome.